Yo, what's up?
Hey, how's it going?
Good, good. So let's talk about visual cortex.
hmm
Let me make, how can I make you host? Oh, make a co-host.
Yeah,
Perfect. Now you can share your
yeah.
screen.
I'll share the screen here,
So
and
what's occipital lobe and where is it? And yeah.
where's my Google? Okay, well, I'll pull up a picture here. Occipital lobe. Yeah, so it's at the back of the brain here, and
Mm-hmm.
this is where like the visual cortex
Mm-hmm.
lies. So the sort of structure of the system is that you have your like eyeballs here, and then they get passed through some intermediate structures that process the input from your eyes, and then they get fed into the primary visual cortex, which is like right there in the occipital lobe. And then from there, the visual information is processed further in the cortex.
Mm-hmm.
It gets sort of propagated to other areas of the brain that do other kinds of processing. Like if you're reading a book, right, you'll go somewhere in the temporal lobe, and that will deal with like language processing. Yeah.
Perfect. I was thinking today that um what's the meaning of colors, right? So if you look at this painting behind me, it's really colorful, right? So
Yeah.
some people are color blinded.
Yeah.
So I was thinking, what is it? Yeah, like and what's the
Yeah.
meaning
Well,
of colors, like yeah.
yeah, I think it's there are sort of two perspectives on it, right? There's like the physiological, like if I'm colorblind because I don't have as many of we didn't really talk about rods and cones in the eye, but like
Mm-hmm.
if I don't have as many of the color sensing cones for a particular wavelength of color, then I just won't be able to perceive that color at
Mm-hmm.
all.
Mm-hmm.
So there's that physiological perspective, but then there's also sort of a neurological perspective where it's like you and I could have everything, if somehow we could share the exact same eyeballs,
Mm-hmm.
even then we may still perceive color differently based on the way that we processed it.
Our brain is being trained. Yeah.
Yeah, our brain is trained. And I think I don't know how much research has exactly been done on this topic exactly, but you could imagine if you grow up in a country that has more of a particular type of color spectrum, right? Like you
Oh
grow up
yeah,
in
that's cool. Yeah.
yeah,
Go
you
ahead.
grow up in a desert country, right? You're going to see more reds and oranges than probably greens and blues. Um, and you probably will grow up to perceive color slightly differently than somebody who grew up in a forested country. Um, isn't it that the like in Japanese they call like green blue? So like you'll
Oh
refer to
really? I didn't know. Yeah.
yeah, you will refer to like green things as like using the word blue. So I mean that's
On
maybe
purpose or
yeah on purpose. Yeah, they
Mhm.
they don't really you know, lexically they don't have like something that differentiates blue and green. They just refer to it as the same thing.
Cool. Yeah, I
Um,
mean that I think it's a matter of labeling, right?
yeah, it's like that's
Mhm.
totally it could be a matter of labeling, but also like, they live in an ocean,
Oh,
surrounded
I see.
by ocean in a very forested country, right? So maybe they like for them, the colors are so ubiquitous that they don't really perceive that much of a difference between them. They just have one label to refer to it. Whereas like, you grow up somewhere else, the color is completely different to you.
Yeah. So what's auditory cortex and temporal lobe?
Yeah, so auditory cortex is sort of the
Maybe you can sorry.
yeah, let's look it up
Okay.
here. Auditory
And
cortex.
I wanted to ask you, um, yeah, to
Mhm.
conclude, can you tell me something that is similar to being color blinded but in auditory cortex? And yeah,
Yeah. Yeah,
go ahead.
okay. Well, we'll unpack that kind
Perfect.
of by starting first with like what is the auditory cortex.
Mm-hmm.
So just like with the visual system where you have your eyeballs and then that receives input from the world and processes it and sort of sends it to the occipital lobe where the primary visual cortex is. With the auditory system, your ears do the same thing, right? So your ears are picking up, these frequencies, right? Sound from the world around you, and then they go through these
Mm-hmm.
various processing stages, and it sort of bubbles up into the primary auditory cortex, which is like right here. And then from primary auditory cortex, it propagates outwards, and that's where you have, you have your language processing is like here, right? Goes to frontal lobe for like other stuff. So the information just sort of spreads out and gets processed in different ways depending on what you're listening to, right? So music would get processed differently from like speech. So you asked about, so I mean the temporal lobe deals with language. That's something that we're very interested in. You asked about,
Language
like,
blinded.
yeah. And so yeah, what is the equivalent for like color blindness for auditory? It's a hard question.
Yeah, deaf maybe.
Deaf, yeah, I mean that's sort of the
Or like hearing loss, but
sensory.
not maybe like like having severe, hearing loss.
Yeah.
Yeah. Can you actually go to the? I think I shared a short on YouTube.
Mhm.
You wanna go um no, I don't think it's gonna pull up like that. But yeah, go ahead. No.
Oh, why not?
Oh yeah, perfect. Yeah. To go to the channel. So yeah, hearing loss. Yeah, if
Yeah,
you play
this
that
one.
one. Yeah.
So guess what I ran into from high school the other day? Who? Janice Thompson. No. Yeah.
Excuse me, lady. How's everything going? Good. You're tuning out good. Oh, here, I'll take this one.
This is interesting.
So guess
Yeah.
what?
What do you
It-
think? Yeah. Like it, please. Like it, please. What
Did
do you
they,
think?
to simulate this, they just low passed
Yeah,
the
exactly.
speech?
But that
It's
one
interesting.
was real because the criterion, I think, I had a conversation with one of the managers, was that, so yeah, they put a filter on the
Mhm.
voice, and the output gives you another signal, right? And then from the signals that they're recording from the hearing aids, they can also reconstruct the same signal. They minimize
Yeah.
the error between this
Yeah.
two.
Okay.
Yeah. But it makes sense also, right?
No, it makes complete sense. It's
Yeah,
interesting. Like you see with the, as you go from normal to like
exactly.
moderate
Yeah,
hearing loss, like all the S's, which have like a lot of high frequency,
exactly.
and it's like they're just cut out.
Perfect. So what do
Yeah.
you think? Colorblinded and maybe
Well, I mean,
moderate severe hearing loss, sorry.
the analog's definitely there, right? Like, so it's like with, in the case of color blindness where you have some cones that are not functioning correctly, you can totally have like in the cochlea, like inner hair cells, outer hair cells that like are not correcting for gain, or not picking up frequencies properly. Totally makes sense. And as you get older, right, some of you can get damage to these the inner hair cells or outer hair cells, and that's what causes age-related hearing loss. At least it's one of the factors, right? People think of those as like actual hairs. They're not. They're more like muscle fibers or something. They're completely different. But yeah, so they don't just fall out. If they don't grow like a hair and then fall out when you're old. Anyway, tangent.
Perfect. Yeah, I think we should also talk about aging projects sometime in the future.
Yeah,
But
definitely.
yeah, thanks for your time. I think it's a good place to stop, and talk to you soon, man.
Yeah. All right. Thanks.
Thanks.